right, continuing in our discussion of 7.4 and negative exponents. So in the last video, I showed you how to do the negative exponents here with quotient rule, and then using our idea that the negative exponent is a reciprocal to simplify this. However, I find that a lot of students have difficulty with the integer operations that you see right here. So in order to avoid those, there is a way to avoid them. What we can do is we can, first of all, take into account these negative exponents. So remember, a negative exponent's not where it belongs, so I'm going to put in the fraction bar. Well, this negative exponent says it belongs down in the denominator. And this negative exponent says it belongs up in the numerator. And now I'm ready to go ahead and do my integer operations. And so we have 2 minus 8. And this one students usually can handle. 2 minus 8 is a negative 6, and that's still 1 over x to the 6th power, which we know that one is the same as this one, so we see it's absolutely correct. So that's just an option. Now you don't have to do it that way, it's just an optional way of doing it, and if you find yourself making mistakes, especially with integer subtraction, it's a method that you might want to use. Right, now our next one, we're going to be looking at some numbers, so we're going to simplify those as well, right? 2 divided by 2 is 1, 4 divided by 2 is 2, and then this negative exponent says it's not where it belongs. So we're going to leave the 1 in the numerator and the 2 in the denominator. Neither of those move. Make sure that you don't move those. Those don't have negative exponents. The only thing with a negative exponent is b to the negative 3, which tells me my b belongs down in the denominator. So I put b cubed down in the denominator. Notice it doesn't have a negative exponent anymore. That's what happened when I moved it. All right. Okay, so now we have another one that's complicated here. So first of all, we could just deal with this straight up. We say we're going to copy the like base and we're going to subtract the numerator minus denominator exponents. And so copying the like base, a plus b, and then this says 5 plus 7, which is 12. And so we get a plus b to the 12th. Remember, that's not the same as a to the 12th plus b to the 12th. This is not distributive property. Exponents do not distribute. However, that's not the only way we can do it. The other way we can do this problem is we can take a look at moving this to the numerator. So we have a plus b to the 5th power, and then we're going to move this up to the numerator. So now we're going to have also a plus b to the 7th power, and now what you see is we just turn this into a product rule. So we copy the like base, a plus b, and we add the exponents. So it's a plus b to the 5 plus 7, which is 12. And you see the exact same answer. So we avoided any integer operations at all on this particular problem. All right, moving on to our next one, we see, oh my goodness, we have all kinds of negative exponents. So one of the things that we could do is we could simply, look at our numbers and we say nothing happens with numbers, so I'm just going to leave the 2 up there in the numerator. And then the fractions, right, 3 minus 1, which is a squared. And then we have the minus 2 minus a negative 3, and that says negative 2 plus 3, which is a positive 1. And then there's no denominator left, right? And so we just have to say this is our final answer. So that's one way of dealing with this. The other way of dealing with it is so that we don't have any negative exponents at all. So I have 2 times a cubed over a. Notice how I wrote all the ones that didn't have any negative exponents. Now I'll move the ones with negative exponents. So the negative 2 up here, that means I'm going to move it down to the denominator. And then this negative exponent down in the denominator, I'm going to move up to the numerator. And now I can do my quotient rule, and 3 minus 1 is 1, and 3 minus 2 is 1 as well. And so I have 2 times a squared times b to the 1st power. The same answer I got before, but this time with no exponent rules here that deal with the integers. Okay, we'll come back and finish talking about the couple of problems